For today's lesson, we're actually going to come back to section 8.3. We spent a lot of time in there, a lot of different things going on, and we're going to look at simplifying the radicals section. And just like we did all the factoring to lead us into the solving, we're going to do simplifying radicals to lead us into solving radicals. So this whole appendix is algebra skills that'll help us do things we want to in math. So it's really like a skill building process thing. This is from the internet, so you know it has to be true. Please don't do silly things like c an x squared over an x squared like this, where they're add and subtracted terms and just cancel them, because clearly bad things happen, and that's really sad. All right, a few simple steps. You've seen this stuff before. We're going to do longer examples with it, and also hammer this domain thing again that we actually started day one with. So 3 simple steps: factor, express your domain, and cancel. We're going to do all the operations: adding, subtracting, dividing, multiplying, but we just want to start with simplifying radicals. You see something like this, again, bad things happen if we just do this. So you look at your steps, we say factor top, factor the bottom. Now, this may be new, this express the domain piece. If you look at this, before you do any canceling, you want to express the domain. So x cannot be a -2 or a -1. We discussed that on day one because you can't have zeros on the bottom. Again, the top doesn't matter here. Now you look at it and you say, oh, well, one of these divided by one of these does cancel. If they're multiplying and their products are blobs, they will cancel out of there. The reason you grab the domain first is because you're eliminating stuff. So if you just grab the domain after, you miss one of the pieces to it. Okay, so this graph here, and we'll get into graphing those, it has holes, it has gaps, it has asymptotes, different things. So you grab your domain before you cancel. Okay, so there's just a straightforward example there. All right, 2 more here. I'm going to do the first one with you guys. So we go through our steps down at the bottom here again. So factor, we see a difference of cubes. Following our formula, let's GCF this one on the bottom. Now, when you're doing these, look for common terms, because you know things have to cancel, especially when we get into common denominators and whatnot. So if I factored this top and I got an x minus 2, you can be pretty sure there's going to be an x minus 2 on the bottom. Okay, so look for things that are in common. That'll help you factor. So we get here, express the domain. X cannot be a 0. That happens twice, and it cannot be a 2 as well. Now we can cancel some stuff. X minus 2's will cancel right out of there. Nothing else is going to happen. You don't want bad things to happen to kittens, so we're not going to cancel those x squareds out of there. If we were able to GCF another x out, then we could cancel, but not in this case. There's one more example here. I'm just going to pause it and show you guys the solution to save a little bit of time. If you want some extra practice, give the video a little pause and see what you get. So after this one factors and I grab the domain, you take a look at it. 4 minus x and an x minus 4. These will cancel, but it'll turn into a -1 because they're exactly opposite. Not one of the pieces, but both of the pieces are opposite. So it's like if you took one of them and you distributed a negative through it, this is obviously the same as this, just rearranging the order of those things. Okay, so that one's a little bit different. Now, apply that -1 to either the top or the bottom, but not both of them, or you changed it back to an original. So just apply it either top or bottom, but not both, because that's the same thing as +1. And there's your answer there. Again, get that domain before you cancel. Okay, now we move into our operations. So now that we know how to simplify them, same idea. You got a rational times another rational here. Basically, it's a factor and cancel type thing. Okay, so you've seen these before at the tail end of Algebra 2. So now we're going into more depth with these things. So I'm going to pause it here, get this factored, and then meet you guys after we grab the domain. Again, when you're factoring, if you end up with x minus 1s on top, you can bet you're going to end up with some x minus 1s on the bottom. Okay, so look for things that are going to cancel that can kind of help you out with these factorings. Now, this one's a little bit interesting for the domain because of this piece right here. The smallest you can turn this x squared is into 0. A negative number would make it positive. You still have that plus 1. So this domain is all real numbers. So we're not going to worry about this. But 0, negative 2, and 1 aren't allowed. So now that it's factored, you've got your domain, you can start canceling stuff out. Now, these things are multiplied together, but remember, it's just like one big multiplication thing. Same idea if you had like 2/3 times 9/4. You could put the 3 into the 9 because it's really like 2 times 9 all over 3 times 4. It's the same idea. You can't cancel top and top or bottom and bottom, but you can cancel top and bottom. So let's get rid of this. Let's get rid of this. An x minus 1 with an x minus 1 and figure out what we have left. So I'm going to throw the 4 out first. You got an x minus 1 left. On the bottom, we got an x and an x plus 2. And it's okay to leave these things not distributed like this, okay, particularly on the bottom. Okay, but that looks pretty simple to me. If you did distribute, obviously that's fine too. Okay, but again, grab that domain before we cancel. So it's just kind of one step up from simplifying there. Quotients of rationals. You guys remember quotient? It's the same thing as division. Now, before we get into this, you have to tell me how you're going to divide fractions. I don't know, let's do 2/7 here. So you don't divide fractions, you multiply by the reciprocal. So this would be 7/4. If I gave you 3/4 over 2/5 like this, we should be able to do this by hand. Write it out this way, and then take the first one, multiply by reciprocal, so 15/8. Okay, same idea with these rational things. So I don't like the way this is written, so I'm going to write it and also factor it as I go through in a more convenient way for me. So I'm going to take this piece and divide it by this piece. Okay, we see another difference of cubes down here. So we're getting better with those. Okay, now you may be tempted to try and grab the domain now, but this isn't the problem we actually want to do because we're dividing by this second piece here. So what's on the bottom right now isn't going to be on the bottom when we actually do the problem. So therefore, let's get the problem all set up. We don't divide, we multiply by reciprocals. Now as we do this, you'll start to see there's things in common, so we can find stuff that's going to cancel. Here's where you grab the domain, because this is the problem we're actually one step away before we start canceling a bunch of stuff. So we grab our domain not from division, but from when we're ready to start canceling in the multiplication. So there's 4 different things the domain can't be. These are important because when we get into solving these, you may get extraneous solutions that we have to cross off in the end because you initially said it's not going to work. Okay, so now we take a look at it. X plus 3 will cancel with this. X minus 2 will cancel with this. And that's about all we can do. So to get a finished answer, figure out what's left on the top and what's left on the bottom. And again, it's okay to leave these in factored form. Okay, we're trying to make the problem simpler, not create all this extra double distribution at the end. Okay, so multiplying, division are the same thing, but it's important to talk about flipping that second fraction and multiplying when you divide. The last two main operations we do in math, addition, subtraction. We're going to look at some subtraction ones because addition is basically the same thing without one additional step. These are a little bit different. Okay, I put the steps over here on the side for you. And again, you did this at the end of Algebra 2, but it was probably, rushed and just kind of an exposure thing. Now we're going for mastery of that concept. So first thing, we want to find a common denominator, multiply each piece by what it's missing, simplify the top, and leave the bottom factored. Okay, and also make sure we grab the domain in there as well. This common denominator idea, I think the easiest way to look at it is something like this. If I ask you to add a half plus a fifth, I'm going to ask you not to go to your calculators, but rather everybody would say, okay, common denominator is 10. So what do you have to do to get to a 10? You multiply the bottoms by 5. Well, 5 and 2. Now, you can't just randomly multiply by a 5 unless it's 5 over 5, because that's 1. 2 over 2 is the same thing as 1, so you're not really changing anything at all. You can multiply by 1, and it doesn't change it. So then this is 5/10 plus 2/10 for 7/10. Keep that same idea in mind. Use different colors and think about what you know about fractions. The stronger you are in fractions, the better you're going to be in these math classes. So we take a look at this thing here. Because we're going to be creating a common denominator that uses the pieces of each other, kind of like each one of these has a 5 and a 2, we can go ahead and we can grab the domain now. So x can't be a 3 or a -4. Okay, common denominator. It's just like this fraction problem here. So common denominator, I'm going to need an x minus 3 and an x minus 4. Multiply each piece by what it's missing. So what is this one missing to get it to the common denominator? It's got to be an x plus 4 over an x plus 4. Same idea here. This is missing an x minus 3 over an x minus 3. It's the same idea that we did with the fraction problem. Okay, you have to do that top and bottom. Now, we've done the second step. Third step says simplify the top, leave the bottoms factored. So on the top, we distribute, we get here. This is an x plus 4 and an x minus 3. The subtraction sign you have to watch out for, because we're basically doing this problem right here. And that's obviously going to change both those signs in there. I use a bracket and come back and take care of that at the end. Okay, addition, you don't have to worry about this piece because it's not changing anything. Subtraction, you do. So now we get to here. Okay, I'm going to put this all over one term, just like I have these two steps right here. It's the same idea right now. I could combine it to 7 over 10. As soon as you have the same denominator, you can write them over that common denominator. So everything for me now is over an x plus 4 and an x minus 3, and the domain still works. Simplify the top. Now, throw that negative through there. Okay, it's okay to leave things like this. You could pull that 2 out of there if you really wanted. Nothing should cancel or reduce for us because of the way the problems are constructed. You're creating common denominators. You shouldn't have reducing afterwards, especially with these rational equations. So that was a simpler subtraction one. Let's take a look at one more, a little bit more complicated. Okay, find our common denominator. So really hidden within that is the idea of always factor. Okay, your common denominator is not going to be this times this. It's like having a 2 and a 5 on the bottom before, but making your common denominator 100. Common denominator is 10. You make it 100, your problem gets really big, and you have a lot of simplifying to do. So if you factor, it'll help you find the smallest common denominator. So let's do that first. The factoring's pretty basic with these, and it should be. Okay, look for things in common. You know you're going to have either an x plus 3 or an x minus 3 here. Okay, in this case, it is an x minus 3. Let's go ahead and grab the domain while it's all factored. All right, common denominator now. Take everything in the first one and figure out what you're also missing. So I need both of the pieces in the first one, and I need one of these. I'm good here. I already have an x minus 3. I don't need another one. So if over on the side, you want to write out what your common denominator is, that may be helpful. Okay, these 3 pieces make up my common denominator. Move to your second step. What is each piece missing to get it there? Well, this one's missing an x plus 4 over an x plus 4. Got my common denominator. This one's missing an x plus 3 over an x plus 3. Now I have the common denominator. Now we're just going to go ahead and simplify. Be careful with that minus sign, so I'm just going to use a bracket. It doesn't matter what order you write these on the bottom. Okay, we're going to go ahead and simplify the top. I'm going to save it here and save a little time. I'll meet you guys with the final solution. Okay, notice as I went down to this step here, I didn't copy that common denominator again because I knew I still had to simplify the top. So it's just kind of a saving a little bit of time piece there. So once I simplified the top, I went ahead and threw that common denominator on there. Notice the domain piece still matches up, so that's good. Okay, that's all I'm requiring you guys to look at. I am going to do one more if you guys want a little additional practice with that. If not, we'll see you in class with questions and some time to practice the skill. Okay, here's an additional practice one if you wanted some help with that. So in the common denominator, we said to factor, so we'll go ahead and do that. So again, you know you're going to have either an x minus 7 or an x minus 1 in there. Oh, plus 4, that's not going to work. How about a plus 3? Okay, while it's factored, grab your domain. 7, 1, we already got a 7, negative 3. Okay, common denominator. I need everything here and what's different over here. So I need those 3 things. Multiply each piece by what it's missing. So this one is missing an x plus 3 all over an x plus 3. And I would encourage you to use those different colors. They'll really help. This one is missing an x minus 1 all over an x minus 1. Now let's go ahead and simplify. Got those there. Minus, I'm going to do a big bracket. Plus signs, you don't have to worry about it. Just distribute those. We'll take care of the negative later. I'm just going to put a line there, but not write the common denominator. I'll just put it in at the very end, just to save a little bit of writing. Okay, maybe we can put common denominator down here. X squareds actually cancel for us. So this one just turns into 4x on the top, and then don't forget about that common denominator. Okay, there's your final answer. Again, this matches up with their domain, so we're good. Hopefully that extra example helped you out. Again, bring questions to class and we'll practice the skill tomorrow.